Hey, folks, good morning. Hope everyone is enjoying the conference so far. I certainly enjoyed it yesterday, so appreciate you being here. And we're going to talk about the top 20 secure PLC coding practices or programming practices. Um, Let me just go to the next slide. A little bit about me. I've been around the industrial controls world for quite some time, been doing ICS or OT cybersecurity for the past 8 years. I'll go into a little bit more detail about what ICS and OT is, just for those people that are as familiar. But we'll spend some time on the basics. I currently work for a company called ICI, and we provide various cybersecurity solutions specifically for the OT community. In the past, I was with GE, being a service guy, being an engineer, and a sales and service manager for quite some time. And you'll see this quite a bit in the OT world. A lot of people work in many countries just because you get to travel. It's a smaller community than traditional IT. My contact info is on the bottom left, and the project contact info, and I get these forwarded as well on Twitter, and the PLC website is right here. All right, so let's jump into the agenda. We're going to talk a little bit about the industrial control systems, the Purdue reference model, how ICS and OT is different from IT, the impacts that we've seen so far from the various threats, the vulnerabilities that are well known in the PLC world, and the insecure by design system, and of course, more details about the specific project, why this list, what's in this list, what is this top 20 PLC coding practices list, and then a few examples to get you a good feel for what they are. And I'll be kind of monitoring the session chat here. So if you have any questions, just put them in the chat. That way, let me go to the session chat. All right. So next up, basics of industrial control systems. If you're familiar with it, maybe this is a good rehash. Control systems existed for a long, long time, even before electronics, before digital. They were based on pneumatic, which is air, or hydraulic, which is oil. So steam turbines and equipment that ran as control systems existed for a long time, hundreds of years. Now, of course, everything is electronics based. You'll hear these terms SCADA, which is supervisory control and data acquisition, programmable logic controllers or PLCs, or distributed control systems or DCS. These are all different things. They kind of developed from different use cases, but over time, maybe the usage is kind of blended because a lot of these systems are now more than capable of being what the other was intended for originally. But you'll hear these terms in the industrial controls world quite a bit. But the key in the industrial control system compared to a traditional IT system is there is a cyber physical aspect to it. There is something that's rotating, spinning at the end of the electronic series. Or there might be a valve that's opening and closing, allowing for some kind of fluid in a water or oil to move. So there's always a cyber physical aspect or component to it, which impacts safety, right? The traditional ICS vendors are, for example, Schneider Electric, Rockwell Automation, Honeywell, GE, all these different vendors that provide industrial control systems are kind of different from your traditional IT providers like Cisco or Fortinet or Palo Alto, for example. Now, these industrial control systems are used in multiple industries. Most of them are critical infrastructure. So, power generation, oil and gas, pipelines, for example, mining that we have quite a bit in BC and in Alberta for sure, oil and gas, and then air, rail, and road transportation. And my company does a lot of these water and wastewater treatment utilities, but even healthcare, right? So, a lot of use cases in different industries. Now, the Purdue reference model, this is kind of like the basic to understand how the industrial control systems are typically organized, right? Or how you can get a better understanding for what systems are out there. So it's a hierarchical structure from 0 to 5. You typically see the level 0 as field devices, sensors for pressure or flow or temperature, and then the valves that I mentioned before, or any kind of electromechanical components at the far end. These are considered level 0. And then level one would be the controllers we'll talk more about today, the programmable logic controllers or the SCADA or DCS controllers. And then level two would be these human machine interfaces, the HMIs. Now, traditionally, this was what considered ICS. And then, of course, you have this level two or level three, where you have these same kind of human machine interfaces, but for a wider area network. So maybe this covers more than one site. Maybe there is a historian that covers more than one site. And maybe these days, even a domain controller that has, multiple sites under it. And then these engineering workstations are those that are used to program these controllers. And so you download logic or code from these EWS to the field controllers. So you'll hear this term OT as well. So it's kind of blended these days. So what OT or ICS means, most people use OT and ICS synonymously, so they mean the same thing. Or you could perhaps think about ICS as traditional industrial control systems with these sensors, controllers, and user interfaces, and maybe OT as those that are what historically were IT hardware, like a Dell or HP computer running Windows that is used in the industrial world as this HMI or this engineering workstation or even this historian. But it doesn't really matter as long as you understand what the other person means when they say OT or ICS. We're on the same page. Now you all understand IT quite well. The enterprise zone, the internet DMZ, the firewalls, and anything that's in this DMZ is typically ending the IT kind of logins or any kind of IT internet access here, and then have a separate jump server or something to get into the OT LAN. So this is typically what we expect people to follow. Not that every site is like this, right? So a lot of sites have very flat networks. We'll talk about that in a bit. There's also this current use case where a lot of IoT implementations, directly accessing cloud services that are directly getting to the OT network at the very bottom, level 0 through 2. In our world, it's typically dubbed as industrial Internet of Things as opposed to just traditional IoT, but the same concept. Now, ICS and OT is quite different from IT in a lot of ways. So in the IT world, we're trying to focus on the CIA triad because the idea is to protect information from unauthorized disclosure or losing integrity or availability. However, in the OT world, there is an alternative triad that's more important or more relevant. So safety, reliability, and productivity. Safety obviously is paramount because, like I mentioned, cyber physical, there's always something at the end that's moving, that's rotating, or impacting physical process. So you need to be safe. You don't want to hurt people. You don't want to damage equipment. So safety is paramount. So a lot of cases have backup systems, backup relays for the PLC, for the controller, so that if the PLC fails for whatever reason, you have something else that can stop the damage or the accident from happening. Similarly, safety functions, which are specific applications, specific logic and hardware that kind of has a backstop to the basic processor, which is in the PLC. Similarly, the hardware, even the traditional PLC, is developed for reliability. For example, operating in higher temperatures, out in the deserts or out on the deck, much higher weather conditions compared to, being in an air-conditioned room, right? And also for longevity. Many of these systems operate for 15, 20 years or more, so they're built in a different way, okay? Now, like I mentioned, flat networks are much more common in the ICS and OT world. Again, because of tradition, because of history, because many of these things were not connected to the internet, so it made sense for a common architecture in a site so that one person can manage from a central location. They don't have to worry about segmentation. They didn't have to worry about isolation. And we'll talk about access and authentication in just a second. So, because of this, the software and protocols that were built for this world, for this OT world, way before IT, right? These were built before many of the IT protocols were available. They were built with functionality in mind. So there was no authentication, no encryption. It wasn't required. It wasn't part of the puzzle. Plus, when you needed time-sensitive delivery, you need less overload, right? So less anything overhead, so that you're not impacting anything for loss of packets, for example. So these systems are dubbed insecure by design because they were never intended to be secure in the first place. So no authentication, like I mentioned, historically for level 0 and level 1 devices. Level 1 device is what we'll talk about, PLCs. The IoT devices, like I mentioned, with new connections directly to the level 1 devices or level 0 devices, they're bringing on an additional risk on top of the fact that these about structural problems exist, right? Now, IT solutions don't always apply to ICS or OT problems, even if the hardware is very similar or exactly the same. For example, the if you're talking about IAM, the HMIs cannot be logged out. So if you're trying to authenticate somebody, if you're trying to identify somebody and expect them to log in and use multi-factor authentication, for example, you don't want that to be a problem. And the operator has to adjust something for process reason, and they're fiddling with their two-factor authentication key, or they forgot the password, or anything like that. So typically those user interfaces are open, they're always on, there's no password to get in, right? Similarly, the DLP, data loss prevention, if you're trying to restrict access to the PLC, for example, but that might be the only way to download controller code, or have an update on an alarm or something like that. So you can't use traditional IT kind of solutions here. Similarly, if you're trying to use a firewall, even at that level 1, where it's an industrial protocol, maybe you have a special firewall. But if you're trying to, configure something too strict and, drop packets, if you suspect something based on an ACL, but then that drop packet is critical for the process to run safely, then that's a problem, right? So the configuration and the rules will be slightly different there, and maybe you don't want to drop all packets in case something is wrong. Similarly, patching on the HMIs or even on the firmware level for the PLC might not be available at all, because this is an older PLC, 15 years old, maybe out of support, but you can't replace it, obviously, for availability reasons, or maybe you don't have the budget for it. And other times, even if there is a patch and you apply it, it might not reduce the risk at all, because like I mentioned before, these protocols themselves are insecure by design. So yes, you patch the HMI, yes, you patch the PLC, but someone used a legitimate port, legitimate protocol to access something because they got in through the IT network, and they're still able to impact the PLC. So what have we seen because of that, right? So the threats and impacts we've seen consistently over the many years, moving from right to left. We had the Shamoon and the NotPetya that came in from the IT world, destructive malware that caused a lot of havoc in Saudi Arabia, and then of course Ukraine, and also ransomware. Most recently, of course, the JBS and Colonial, which kind of put this in the spotlight. But even before, a lot of OT systems were impacted because the ransomware came from IT. WannaCry, for example. And then we've also heard recently about the Oldsmar, Florida incident, where someone was able to remotely access, because the remote access was insecure, using a published password, and were able to adjust the concentration of sodium hydroxide 100 times more than what the available or the allowed concentration was. So there was another one here in Kansas as well. So these things, are from the OT side, and many of the ransomware attacks happen from the IT side. But then there's also traditional industrial control systems being affected. Stuxnet was the first famous one from 2010, all the way to Triton, which was in 2017, affecting safety PLCs in Saudi Arabia. So these systems were affected with a physics payload. Essentially, someone was using a replay attack on the PLC or infiltrated the supply chain, even though they were air gapped in Iran, for example. So the threat actors obviously ranged from APT nation state all the way to criminals and hacktivists and some malicious insiders. So there's a whole spectrum here. But if you think about what gets the most news is this side, right? So most of the IT ransomware or the OT insecure remote access takes most of the precedence in public news. But there's also this aspect which impacts the PLCs or the controllers themselves. So like we discussed before, the PLCs are vulnerable and they're insecure by design. And you see some news items here talking about how a certain project mentioned the PLC was just open, very easy to exploit, and then all these vulnerabilities. So why are we talking about PLC vulnerabilities or PLC coding if everything is just so bad, right? That's the main question that we're going to address today. So why is this list relevant? So let's take this sample example, this scenario where ransomware has affected some of the IT systems and you took a precautionary outage. This is no different from what happened at Colonial, right? So Colonial had some IT billing systems affected and then they shut down the whole pipeline. So you're trying to remediate the IT systems, right? But before restarting the process, it's only logical to ask, have any of these OT systems being affected, right? And traditionally, these OT like HMIs or EWSs that we mentioned were Windows based. So the traditional endpoint protection or maybe some kind of network monitoring can help you answer. Nothing fancy, right? I mean, just endpoint, maybe antivirus would flag something, or maybe your Cisco router, gives you some feed, some information on what happened in packets, right? That's possible at the level two or above. But how about the level one? If somebody asks you this question, are the PLCs affected, the controllers affected? Can we restart the process safely? Then this question, is it possible to answer using native functionality in the PLCs? We think so. So back in S4, it's a conference in 2020, January, Jake Brodsky did a presentation about all the different good things we can do within the PLCs without installing third-party tools, without having to invest in separate IT appliances. There are things that we can do to kind of answer this question. So that's how this Top 20 Secure PLC Coding Practices project was initiated. We had more than or close to 1,000 people register on the website. Several dozens contributed. We had regular meetings for a year, and then this June we were able to publish this version 1.0. It's available on the website for free to download, and you can use it as you see fit because it's a community effort where you can use it for improving your programming practices. Now, what's in this list, right? So this is the level one device, right? The PLC or the communication controller, and then you have level one, which is the HMI or the user interface, and then the level zero, sensors and the field devices. So we try to restrict our PLC coding practices list to just this PLC because there are other things you can do at the level zero and the level two level to improve security, but we try to focus on the native functionality in the PLC itself. So any code that impacts the PLC, we try to come up with items to improve the security posture there. And then potentially in the future, we'll add this environmental practices that kind of covers the others. Now, this is the list. We have 20 of them. You can go to the website that's on that slide too. The link is available, so you can download the PDF for free. You don't have to enter any information. We're not collecting anything. It's just a free PDF to download. It's about 40 pages. It has these 20 practices and all the details regarding the practices. But we're going to talk about a few of these so that you get a good feel for what these practices are and how they're relevant to the controllers and the process safety. Let's start with something pretty simple, pretty straightforward. The practice number 16. By the way, these practices are not ranked. So even though there are 20 of them, it's not that number one is more important than number 20. All 20 are, for various reasons, important for your process, and you can kind of look at what's applicable to your particular situation, your particular process or plant, and then adjust accordingly. So practice number 16 says summarize PLC cycle times and trend them on the HMI, the user interface. So cycle time is the time it takes to compute each iteration of the code or the logic in the PLC. And mind you, these programmable logic controllers, these are all deterministic, meaning you provide them certain types of inputs, you expect certain types of outputs, and everything is known, everything is deterministic. So the cycle time should be constant on the PLC unless there are changes to the code or logic or something else in the process, right? So if you trend them, for example, as this bottom right shows, you'll see some minor variations, but let's say someone is trying to execute some malicious code, you get this spike, right? So you're able to see that every so often there is some additional code execution, so they can you can do some investigation. We don't call it forensics; we kind of call it troubleshooting in the industrial world. But you can kind of look at it and say, "Oh, something is wrong," right? Now, traditionally, PLCs have a limit. The cycle time, once it reaches a maximum cycle time, it'll stop the PLC so that the hard stop comes into effect. So malicious actors are well aware of it, right? So they try to keep the additional code clean or lean so that you have some variation, but it won't reach the maximum, which is why I think this trending and logging is important. And so you can have this kind of band where it's allowed, but then once it crosses a certain band, you can set an alert. We call it an alarm in our world. So you can set an alarm for the operator. And of course, if you have this on the HMI as a trend, the operator can easily see that in every so often there is something going on that they can alert the engineers, the controls engineers to come investigate. So visualizing values over time draws attention to anomalies, right? Now, next up is practice 12. All threats. Oh, Jason, yeah, thanks for saying that. Yeah, pretty high. Yeah, you're right that most of the threats in the public, so far that we've seen came from the IT side, usually ransomware or some kind of easily accessible, internet-based attack, right? That's why if you go on Shodan, for example, you'll see a lot of internet-facing controllers, and most of the attacks come from that way. But there's also, the supply chain attack, like we mentioned, the Stuxnet is a good example. Nation states have other avenues, obviously, to attack, these process plants, all the way to Triton. These physics-based payloads, these supply chain attacks are few and far between. Only 5 in the past 10 years, but they're significant. And if your threat model involves that, for sure, need to be considering that. But next up, this practice number 12, validate inputs based on physical plausibility. This is an interesting one because if you look at the practice, it has a few examples. So, one, monitor expected physical durations. For example, a gate on a dam would take a certain time to go from fully closed to fully open, and you know what that is, right? So if the gate is suddenly taking too long, then there could be a mechanical problem, right? Or it could be that someone is trying to force it closed or force it open or force it to be not fully open. Right, it's possible that someone is trying to affect it. So, if you alert on this that hey, the gate is supposed to open in 2 minutes, but it's stuck, um, that should be definitely an alarm, right? And it would be in a critical loop anyway because they're trying to make sure that the gate goes to fully open. But there is also a cybersecurity benefit to tracking this. You'll see that theme across the board in all these practices that many of them have reliability and maintenance benefits, but we're also trying to, as part of this practices list, focus on the security benefit of it. In case you didn't configure it for a maintenance benefit, consider configuring it or programming it for a security benefit. Similarly, monitor expected physical repeating activity. For example, the wastewater treatment plants, they have this diurnal cycle. So what happens in the morning versus what happens in the night, or maybe in a batch process, what happens at a certain time during the day and then in the afternoon versus evening. They all should be consistent, right? So you're trying to get a particular batch out or you're trying to get a particular type of quality in the water. But if for whatever reason they're different, someone is trying to influence it by changing something and changing the treatment methodology or dosing methodology or something like that, you should be able to highlight or alert it based on this, not being repeating. It should be repeatable, but because it's not, you alert it. And then limit operator entry for set points that are practical or physically plausible or possible. As an example for this old North Florida that we talked about before, yes, you had insecure remote access. Yes, somebody was able to exploit that to access your operator interface. Yes, they looked at sodium hydroxide levels and then they entered some value, right? But if you think about it, that value that they entered was a order of magnitude higher, 100 times more than what the typical dosage is, or maybe it was thousands of times. So why is that? Like if you typically need that dosage to be 10 milligrams or 10 something parts per million, and physically the valve can only open so much in a certain duration, it'll take an hour to get to maybe that additional 10 extra parts per million. how would you or why would you have an operator input that's thousands of times more allowed, right? It should not happen. So if the operator can enter only between 10 and 15 or 0 to 15, and the valve can only go from 0 to 15, that's going to align, right? So that way, even if somebody makes a mistake, or if even if someone malicious is trying to affect it, they can only go to that maximum level that's allowed and physically possible in the process. It cannot be anything more, so that you're trying to remove one avenue where someone can affect it, right? Similarly, this other practice, practice number two, I'm showing a picture here. It's an example of a PLC. This is how an Allen Bradley PLC looks. You have this is the safety section. This is the input and outputs called the I/O. Power supplies at the top, and then the controller and the different modules for the I/O processing. And you'll see here that there's a key switch. So some PLCs have this key switch that you can put that in a different mode based on your need. So if you put that in run, it runs the PLC code. If you put that in program, it's still running the PLC code, but you're able to download code to the controller. And if you put that in remote, in some PLCs, it has multiple options. So remote means you can only program remotely, or in other cases, you can actually run or program it remotely. So it just depends on the PLC. But the key is if the PLC is in run mode, it typically cannot accept download to the controller. So people cannot impact by downloading any code to the controller. So if the PLC is not in run mode, therefore this practice says alert the operator, right? So there should be an alarm if the PLC is not in run mode. Now you might be doing something, an engineer might be actually doing something. He's put out his coveralls, went all the way, and turned the switch to program mode because he's doing something. Still, the operator is aware of it because there's a permit open. Somebody's authorizing this download, so he can ignore that for that shift for that 8 hour or 10 hour period. So exception, for example, for this testing or the maintenance window, but at the end of the shift, when the permit is closed, when the operator is aware that the testing is complete, it should go back into run mode so that, it's kind of like a backstop where no matter how or what access was allowed to that level one device, if it's in run mode, obviously you can't download to the controller, so you can't impact or change the code for the most part, right? There are examples of that being bypassed, and that's a different scenario. That's a different level of nation state attack. Now, the PLC does not have a hardware switch. Again, this concept is to track operating mode. So if it doesn't have a physical switch, you can still use some other software mechanisms, maybe use a checksum feature. We have another practice that talks about that. Or some kind of password mechanism to avoid someone being able to download the controller from remote. Um, Next up, practice 13, disable unneeded, unused communication ports and protocols. This too seems pretty straightforward, right? Most controllers and network interface modules support multiple communication protocols. Unfortunately, many of them are enabled by default. So whether it's Telnet or FTP, obviously, we don't use them in the IT world anymore, but because historically they were used in the industrial world, they're enabled, they're available, and like I mentioned, enabled by default. But every enabled port and protocol adds to the PLC's potential attack surface. So attackers can't use them if disabled, right? They have to enable them again to use them. But you can alert if any of these ports are enabled or protocols are enabled, and of course you can detect if a certain protocol or port is in use depending on traffic monitoring and if you have a firewall if available. But even natively you can set an alert or an alarm if a port or protocol is being enabled, which is going to be your path to recognize that something is changing in the environment. So the best practice that's recommended as part of this practice list is to develop a data flow diagram that kind of shows all the required communications, both the physical ports and the logical networks and protocols. So you're kind of aware, even at the plant level, or if you happen to be, a much more sophisticated company organization that has even a SOC, someone at the SOC level too can easily recognize that a certain port or protocol is now enabled when in fact it shouldn't have been because it's not used in the system, right? Now, the other benefits besides security, it reduces the potential for malform traffic on this protocol, for example, whether it's malicious or not, which decreases the chances of the PLC crashing. Mind you, the PLC typically has limited CPU capability, especially the older ones. So there are more ways it can crash in case it's not expecting some traffic, but it gets it, right? So by reducing this malform traffic, by disabling those ports and protocols, you're reducing the chances of the PLC crashing. And overall, the PLC complexity is also decreased, right? You don't have to administer some code that's not used. You don't have to update the firmware, for example, if that particular vulnerable code is not in use. You hear a lot about these SBOMs these days, software bill of materials. Let's say you do in the future have an access to all the different code that's used in that particular firmware version, and you recognize that you've disabled that code because you're not using it. That is probably less of a headache for you because you don't have to update that vulnerable code. You don't have to keep it up to date. Um, we have many more examples like this, but I wanted to end this here because this project is still ongoing. We have a lot of contributors to this. We have been doing a lot of presentations about this, going to different engineering companies, going to different vendors, and trying to improve their security posture by programming the PLCs better, right? But we would like some feedback. We would like some collaborators to spread the word, essentially. We had a lot of collaboration with the MITRE, both the CWE and the attack framework are mapped in the PLC practices list. The CW team is trying to come up with a PLC section. They currently don't have it, but they're trying to work with us and include that in their CW list. A lot of PLC vendors and user groups have been approached, and we're getting some feedback. But you can be part of this. And if you're a PLC programmer or if you're in the OT security, give the list, download the list, spread it to the PLC engineers, the ones that are programming this currently, right? Give it to them, tell them that these are the best practices that the industry is telling each other to follow through. So it'll certainly help. We're also doing a lot of articles and podcasts. So if you have any more questions, by all means, reach out to me. Let me know. We have more than me in the community project. The Secure PLC Twitter handle is a good place to start. You can also go to plc-security.com. There's a formal feedback form there that you can give us feedback on the practices themselves or the implementation. So I will end there, and let's take any questions. Just putting it out there so that you have this PLC handle on the website. If you all need any of these slides or this slide deck, just let me know on this chat or on the Discord channel, and then I'll send that to you. Any questions, folks? Thanks, Marcy. plcsecurity.com. That's right. Let's see. I'll go to the Q&A section in case there's anyone there. Not yet. Yeah, let me know if you have any questions, folks. This is, I guess, an interesting development that we did in the past, probably 18 months or so, because a lot of the OT security discussion or the narrative is top down, coming from internet-based level 5 down below, not so much at the level 0 or level 1. So this is definitely an interesting development. Grant, sure. If you don't mind, just let me drop you my Twitter handle. Yeah, just message me or something, or if you go to this plc-security.com, you can email me there as well, and I'll reply and give you the slide deck. I don't know if there's any other easy way to do it, but if there's a way to upload, I can do it here, but this is probably just as easy. Yeah, this is an interesting portal that we have. I wish we can have a conversation. So if you have any questions or comments, we can share. But it seems to be one way. So I'll stick with the time duration. Maybe spend another few minutes making sure if you have any questions that I can answer.
On this particular platform, voice is limited to people who are moderators. So I will get, if you have any questions, please do drop them in the chat.
Thank you, Marcy. Yeah, in general, I see 13 people. Could you all maybe just mention if you're coming from the IT world or if you're already an OT practitioner? Could you all maybe put it in the chat to see what the background is for those that attended? Just interesting for me to kind of see, where we need to go next, right? So again, this is not a commercial product or anything. A lot of people that contributed to this programming list work for all these different companies, but it has nothing to do with the companies, right? So we're all trying to come together and put a list for community and public use. So thank you, Jason. I appreciate it. IT and OT. Well, that's interesting. So I guess you came from the IT world and are now responsible for OT as well. We see that quite a bit. Um, like Jason mentioned, a lot of threats are coming from the IT world. So we're certainly appreciative of the IT people that are willing to learn the OT world, can understand the nuances, why you can't do a certain thing the same way you do in IT in the OT world, and work with the engineers to obviously keep the process up and keep this people safe, right? So we appreciate that. We have a lot less people coming from the other side, coming from the ICS world and learning IT, though we have some increasingly so. But we need both, right? We need the engineers that do the programming. We need the technicians that work with the hardware. Everyone to learn the importance of security, learn what's going on, and improve the security posture for the organization in total. Grant started out in electronics and control systems and IT networking and IT security. Oh, that's amazing. That's one of the few kind of superstars we have going from the controls world into IT. So that's amazing to know. Rajat Kundu, how to join the community. My suggestion is to start with that website, plc-security.com. There's an email address published there as well. Send a note to that email. It comes to about 3 people, one myself as well. So depending on how or what you want to participate in, if you want to be on the monthly calls, we'll send you that calendar invite. Or if you want just the Teams channel access where we put these documents, where we are doing a lot of translations these days, maybe you want to assist in one of the translation projects, or you want to do the presentation yourself to maybe a local engineering community. We have the PowerPoint slides over there for you to customize. It's a free for all kind of thing because we're not trying to be gatekeepers here. We're trying to encourage more people to get involved. So yeah, the easiest way is to send me an email, which is published on the plc-security.com website, or follow Secure PLC on the Twitter handle and DM me, or send a note on that Twitter feed. And Rajat, what's your background? Are you an IT person or an engineer in the OT world, or what's your background? All right, I think we've been almost 5 minutes in. Yeah, let me answer this question. Engineer starting from control system OT and moved into network security. Oh, that's awesome. So Grant was something similar as well. This is rare, folks. I mean, you're one of the chosen few. I came from this world as well, right? I started off as a controls engineer and then, learned IT. We have IT experts, right? I mean, Jason, for example, is such an amazing speaker. We're so glad to have him, watch this presentation. We definitely can take a lot of help from our IT folks because they solved a lot of problems already. So we don't have to reinvent the wheel, but we should bring our perspective to it as to why certain things are not applicable or should be done differently in our world, in the OT world. But yeah, anyone um, that came from the engineering side in the ICS world, or started out as a controls engineer in the OT world and trying to learn IT, um, you're probably like a third to a quarter of the total OT focused folks these days. So pat yourself on the back that you're one of the few interested people and trying to do the right thing for the greater community. Really enjoyed talking to you all, and yeah, look forward to collaborating further via the emails or Twitter or whatnot. You have my contact info, and let me know if you need the slide deck. Bye, folks.